Hello and welcome back to this topic. This is the second video in this topic, turning effect of a force. And in this second video, we want to see how we actually calculate moment of a force about a given point. In this question, we've got a force of 100 Newton force, and we want to calculate its moment about points A, B, C, and D. I did not indicate point E. I want us to reach point D. I've put this information on a grid. So the length of this grid here is just 1 meter. That helps us to calculate any distances that we want. So remember that we want to calculate moment of the 100 Newton force about a given point. So the complete description of the physical quantity we are calculating is moment of the 100 Newton force about point A is equal to, of course, the force 100 newtons times the distance which makes 90 degrees with the line of action of the force. You can see this is the line of action of the force, and the distance which makes 90 degrees with it is 5 meters. 1, 2, 3, 4, 5. So we are going to get 500 Newton meters clockwise. That direction will be clockwise. How about point B? Moment of the 100 Newton force about point B will be 100 newtons times the distance from this point all the way to this point is 4 meters. So we are going to get 400 Newton meters clockwise. You can see it is slightly less. Why has the moment reduced? Why has the turning effect reduced? It's because the distance has reduced. And this one brings us to one of the factors which affect magnitude of the moment of a force about a point. One of them is the perpendicular distance, and moment is directly proportional to the perpendicular distance. Of course, the other factor is the magnitude of the force. Moment is directly proportional to the magnitude of the force. When we look at the equation that we used for calculating moment of a force about a point, you can see that the equation actually gives us the two factors which affect moment of a force about a given point. And one of them is the force, the other one is the distance. In both of them, you find that moment is directly proportional to each one of them. And we have seen this when we reduced the distance. Let's look at point C. Now, if there was some point here, you would be able to see that its moment will be 1 meter times 100 newtons. It will be 100 Newton meters. So you can see that as we approach, as that perpendicular distance reduces, you see that the moment becomes smaller and smaller and smaller and smaller until when the point about which we are taking moments lies along the line of action of the force here, then we are sure the moment due to that force is 0. And here we identify a fact that is going to help us a lot in problem solving involving moments. And it is this: if the line of action of the force passes through a given point, then the moment due to that force about that point is always 0. It will be very useful when we want to eliminate from the calculation the moment due to certain forces. If we want to eliminate the moment due to a given force in a diagram, then we make sure that we take moment about that particular point, so that any point, any force which is acting through that point, then its moment will always be 0. That way we eliminate the moment due to that force. We will see that aspect in future problems. So the moment due to the 100 Newton force about point C is 0. Of course, the moment due to the 100 Newton force about point A and about point B, both of them are clockwise, but they are different in magnitude. Let's look at the moment due to the 100 Newton force about point D, and we'll see that it will be 100 newtons times 2 meters, which is 200 Newton meters, anti-clockwise. This time it is anti-clockwise, because when we imagine this to be the center of the clock, and the distance is actually the arm of the clock, we realize that that motion is anti-clockwise. And that is how we calculate moment due to a given force about a given point. When you look at the video description, I will put a download PDF where you can download and do the questions that I've included in that PDF. Otherwise, in the next video, we are going to look at the principle of moments, so that now we can start looking at questions involving the principle of moments. So see you in the next video.